Hello everyone. I would like to discuss a seemingly counterintuitive principle of fluid dynamics called the Bernoulli's principle. So let us have a closer look on this principle and understand what it has to offer. So what is Bernoulli's principle? Bernoulli's principle can be interpreted as conservation of energy. It says that summation of static pressure, dynamic pressure, and elevational pressure is constant for a given system. This equation seems mathematical and hard to understand, but it is not. It can be better understood as higher the velocity, lesser will be the pressure on the same horizontal level. I'll be explaining it in a much simpler manner by an experiment performed by me and my sister. So let's have a look.
ક્યાં ને તો તારી માટે એક ચેલેન્જ છે કે તું એક બ્રેથ માં કેટલું આને ફૂલાવી શકે તે જોઈએ. ટ્રાય બસ નાજી દેખાડો તમે.
As you saw in the video that my sister was able to trap air lesser than I was able to. This seems weird, right? As she held the bag closer to her mouth, which means that the air that she blows only goes in the bag, whereas I blew from a distance. The air should have dispersed and lesser air should have been trapped. Here is where Bernoulli's principle comes into picture. What happens is, when I blow the air from a distance, it increases the velocity of air between my mouth and the bag, which by Bernoulli's principle creates a low pressure. And as we know that fluids tend to move from higher pressure region to a low pressure region, is what happened here. The air surrounding the bag was also pushed into the bag to compensate for the low pressure. So, based on this home experiment, we'll see a lot more real life examples which are more relatable. F1 cars are fast and lightweight, which makes them comparable to an aircraft weight to speed ratio, according to which this car should fly. So how do you prevent them from flying? If we increase their weight to counter the lift generated, it will make them slow. So here is when Bernoulli's again knocks at the door and says that the wings in the airplane which makes them fly can be inverted and attached to the front and the rear body of the car, creating a downward lift, which will allow the cars to move faster and prevent them from flying. Thus, now the question comes that is this principle only related to engineering stuff? No, it is not. Even a layman applies this principle unknowingly every day before going to work. Yes, this is a schematic diagram of a perfume atomizer, which is similar to the perfume bottles that we get nowadays. The concept here is we press the bulb, the air gushes through the nozzle and flows over the opening of the spray tube. This causes the formation of a low pressure region over the spray tube opening, and liquid inside the bottle is sprayed as a result of compensation of this low pressure. Have you ever faced a situation on a rainy day? This is another example of Bernoulli's principle. This is a mean and yet an intriguing situation. What happens is the air that is flowing beneath the umbrella travels with relatively slower velocity as compared to the air flowing over the umbrella. So now when the cloth can't take this lift generated, it gets inside out. There are immense applications of this principle, such as in airplanes, in chimneys, in sports, in pipes, and you name. So I would like to conclude by urging you to see for applications of the phenomena that you study and bring them to life rather than letting them die in the books. Thank you.